horrible. All right, ladies, go ahead and take out your devices. We're gonna do pair deck today. I want you guys to answer some questions in the PowerPoint that we've already gone over. So take out your devices and then log in, okay? The code is on the board here. All right, so there's the code on the board, KGABP. If you guys can't see, I'm gonna write it really quickly on the side. Go ahead, joinpd.com and enter the code. And then right when you enter the code, it takes you to this slide right here. It should take you to this slide. Define chemical bond, list the 3 types of bonds, and what is the difference between ions and a polyatomic ion, okay? So if you can't see it on the screen, you can see it on your device. Answer those questions. This is your do now. This is the beginning. I'm gonna give you about 5 to 10 minutes on this, okay? You can use your notes. Try your best to put these definitions in your own words because it's easy to copy and paste, but if you put it in your own words, you're processing it. And then it's a little bit easier for you to remember. So try to put it in your own words. It'll help. All right, so let's see what some of you guys have written. Okay. So, chemical bond is when electrons come together and form a strong pair. Good. A type of force that holds 2 or more atoms together. Good. An attraction between positive nucleus and negative valence electrons. Perfect. I love that this person included that it's the valence electrons that are involved in a chemical bond. If you don't have that in your notes for a chemical bond, that valence electrons are the ones involved in the bonds, make sure you write that down, okay? Yep, a force that holds 2 or more together, 2 or more atoms together. Good. All right, the second question. The second question was the 3 types of bonds. Can somebody tell me, just raise your hand really quickly, what are the 3 types of bonds? Andrea.
Ionic bonds, covalent bonds, and metallic bonds.
Good. Ionic, covalent, and metallic. We've been drawing Lewis dot structures for ionic and covalent, so these you should know off the top of your head, okay? You know it by heart. And then the last question. What's the difference between an ion and a polyatomic ion? Let's see what people wrote. Ions are atoms that lose or gain electrons. Perfect. There's more to it though. Tell me what a polyatomic ion is. Ions between metal and non-metal, that's ionic bond. Close though. Polyatomic ions are composed of 2 or more atoms. Yes, they are. What else? Polyatomic, 2 or more atoms. Poly has multiple. Let's see. Ions and ions gain or lose electrons to become stable. Polyatomic ions are ions composed of 2 or more atoms. Yeah. Make sure that you note that they have 2 or more atoms, but together they act as one group and they have a charge all together. Okay? Cool. All right. Any questions so far? All right. I'm going to show you guys what we're doing today. All right. So I know you can't really see this all that well, but here's what we're focusing on today. Today we're going to be talking about the formation of ionic covalent bonds using Lewis dot structures. We've been practicing this over and over, but we need more practice, okay? We are going to move on with Lewis dot structures as well, and we're actually going to start predicting the shape of molecules using Vesper theory. And then we're going to talk about the domains, right? The domains are the electron pairs. So you started with the do now. We're going to review our homework. We're going to go over the answers, so make sure you have your homework out. Next, I'm just gonna review really quickly Lewis dot and Vesper. We're gonna do an activity and then you're gonna get started on your homework, okay? Cool?
Yes.
All right, both answer keys are on Schoology. Go ahead to Schoology, but here is the first one, ionic and covalent bonding. Here's the answer key on the board, all right? For the first 2, I have them on the board here. The first 2 are both ionic. I'm gonna zoom in to what happens to those actual atoms and their electrons, okay? They're both ionic. Only the top 2 were ionic. Everything else was covalent. So here we go. For the first one, sodium has 1 valence electron. Chlorine has 7. For ionic, I have to make sure that I do what when I'm drawing the Lewis dot structure for ionic? Go ahead, say it. Giving what?
Giving the atom.
Giving the atom, the whole atom? What am I giving? What is this stuff? Yes. The valence electron I'm giving, so I have to draw an arrow. What else do I have to do at the end for ionic? What am I doing here, Bethany?
You have to show at the end of the brackets how much they gained or lost.
Good. So I put brackets, and then I show all the valence electrons, and then I put the charges, don't forget. So I only put one, I gave one electron away to chlorine, which makes it positive one. Chlorine gains that electron, negative one. Cool? And then there's that one there. Magnesium gives away two. One to each separate chlorine. Make sure you write chlorine twice. I don't want to see any of this. I saw a lot of this before in other classes. That's not correct. Why is this not correct? Miriam.
Because you could say that chlorine gained 2 electrons.
Exactly. This looks like it gained 2 electrons, but that's not right. In reality, this one gained 1 electron and another chlorine gained another electron. Okay? So I don't want you to combine both of these chlorines into one bracket. Don't do that. Keep it separate. Okay? I'm going to move on. Can I scroll down?
Yeah.
So here is bromine, covalently bonded to another bromine. I circled the 2 lonely little electrons, and that turned into a single bond. You could have done it the other way too. What's the other way with the math? What do I do for figuring out the Lewis dot by calculating electrons?
The valence electrons.
Yes, so bromine has how many valence electrons? Somebody raise your hand. How many valence electrons for bromine? Somebody, Leslie.
7.
7, and I have 2 bromines. So 14 electrons, valence electrons. How many pairs is that? 7 pairs, yeah. Okay. So then all I have to do is bromine, just immediately bond it, and then fill in the rest, okay? Let's see if that works out. So that's 1 pair, 2, 3, 4, 5, 6, 7 pairs. And do they each have 8?
Yes.
2, 4, 6, 8. Yep. 2, 4, 6, 8. Beautiful. Same thing as that. Look right here for nitrogen. I have 3 bonds right here. So I call this a triple bond. But I also have 3 bonds right here. Why is this a single bond? Why did I classify that as a single bond versus a triple bond? Look at what's happening in there. What do you think? You want to go for it? Go for it, Jennifer. I promise I'll make you look good. Go for it. All right.
I mean, it's single bond because the B is just doing with the F. It's not like it's doing with the same one. So like, I don't know.
So like it's bonded with this
Yeah, with
F?
that one and the other, and it's just bonding the other ones.
Oh, so you're saying there's more than one F and each of them have 1 bond? Versus what's going on here? Why is that different though?
Because that one's just it's bonding the same one, but like the other one is just bonding with different ones, so like that's why.
Perfect. Yeah. So she's saying that you have multiple Fs here, and each of them just have a single bond with each fluorine. This, it has 3 bonds with the same nitrogen. So if it's with the same atom and it has multiple bonds with that same atom, that's triple. Look, same atom. They're all of these bonds are going to nitrogen. That's triple. This one right here, look, single bond over here, single bond over here. All the single bonds, all of this, okay. Single bonds, okay? Moving on. Okay, cool. So, like we just said before, before. So ionic bonding is in between a metal and a non-metal, okay? So you have your metal is giving away valence electrons. Your non-metal is receiving them, and then they create charged ions. Sodium has +1, chlorine has -1, and then they come together because of the attraction of their charges. Covalent is when they're sharing, okay? They all want to have a full valence shell, so they share electrons with each other. And that's between a non-metal and another non-metal. All right? And then we talked about metallic bonding, but metallic bonding is a little bit different, okay? You lose electrons. Metals lose electrons, and those electrons float around. It's like a sea of electrons. And then you have positive metals just hanging out too. So it really is just a bunch of electrons and cations floating around. So go ahead and answer this question on your screen. What kinds of atoms are involved in ionic bonds? What about covalent bonds? And then tell me what happens to electrons in all three types of bonds. Okay, so ionic is a metal and a non-metal, good. Covalent is non-metal and non-metal. So what's happening to their electrons? Looks like people are still writing that part. So what happens to the electrons in ionic? Somebody raise your hand. What happens to electrons in ionic? You know what? I'm going to use popsicle sticks. So get ready. Everybody better be ready. Unless someone wants to volunteer. You want to tell me, Leslie? All right. What happens to the electrons in ionic?
So in ionic, the electrons are given away to the other element?
Yes. So you have electrons that are given away and then electrons that are received. So it's transferring. What about covalent? What's happening to the electrons in covalent? Let's see. Jennifer, what happens to the electrons in covalent bonds? Okay. You have your notes up?
Yeah.
Okay. Somebody want to help her out? Look at your notes. Go to covalent bonds, you guys. It's in your notes. Quran, yeah.
Like it shares.
Yes, perfect. They share electrons. Beautiful. And then lastly, metallic. What's happening to the electrons? We just talked about this. Melanie.
They attract to each other.
They attract. That's a property of metallic bonding. Go ahead, Leslie.
It said that like metal is like floating around.
Yes, they're floating around with metals. Good. Here we go. So, everyone should have a packet. Everyone has a packet? Yes? All right, you're going to spend the next 30 minutes on this. This is going to be your homework, okay? So, in the front, you have a little introduction. This introduction tells you what a covalent bond is, what Vesper theory is, what Vesper stands for. It tells you why molecular shape is super important in science and in the world, really with your body. It affects how you taste things, how you smell, the way that you can see. Molecular shape, the geometry of it, is super, super important for all life. Okay? This paragraph, these two paragraphs tell you a little bit more. And then you have questions on the bottom. Okay? I want you to go ahead and skip those questions for now. You can answer those for homework. So go ahead and flip the page. You have a table. This table is what you're going to fill out. At the top, it says, purpose. You're going to build 3D models of covalent molecules. Okay? You have a baggie full of pieces. Each piece is a specific atom. Okay? So it says, black is carbon. White is hydrogen. Red is oxygen. Blue, nitrogen. Green, orange, and purple. Any of those colors could be chlorine or fluorine. Okay? All the little gray sticks are gonna be how you bond them together. Okay? Notice, everyone take out the black carbon. How many holes does the black carbon have on it? Four. Where's you guys, there should have been 4 baggies. Where's the 4th bag? Okay, it has 4. Just like how carbon has 4 places that it can have a bond. Okay, so those little small holes where you can connect, that's where a bond can go. Okay, how many does the blue have? 3. That one's nitrogen because nitrogen only has 3 spots. Nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. Those are the 3 spots where it can have a bond. Okay? So those little holes tell you how many bonds it can make. So, follow the steps. It says, obtain a molecular modeling set. I already gave that to you. Study the color code. I already showed that to you at the top. Okay, number 2. One person in your group create a model that is in your table.
Okay, so for this one, it says that it says electron, but it only goes up to 2, but this one says 1.
Okay, the reason why these are weird, is your pencil? The reason why these are weird is because usually in your chart, they have one central one and then everything around it, right? But this is just 2 of them connected to each other like that. So this one's gonna be weird. Whenever it's just 2 connected like this, it's always gonna be linear. Always. Okay? Ladies, so someone brought up a really good point. Everyone has their chart, right? We're gonna add to the chart. So take your chart outside of your sheet protector because we're gonna add to it. Okay. If you notice, your chart shows you molecules that have a central atom in the middle and other atoms bonded to that central atom, right? Doesn't all of your the molecules on there look like this, or it has a central atom and it looks like this? Yeah. There's always something in the middle? Yeah. Whenever you have a molecule where it's just 2 atoms bonded to each other, like this, and there's nothing in the middle, for example, the hydrogen that we just did. Another example that you have on there is chlorine, that looks like this. You see how it's just 2 connected to each other? Yeah. That will always be what shape? Linear. So I want you to put on the side of your chart somewhere, when you have, you can literally draw this and then draw the examples like this. And then I want you to put always linear. Always linear. Okay? Draw this on the side somewhere. Okay? Alright, keep going after you've done that. You can just keep working. Make sure you're building, you guys. You better build, because it will help you figure out if it's symmetrical or not. It's kind of hard to tell when it's on a flat piece of paper, but when you build it and see the 3D model, you can see if it's symmetrical, you can see the shape. Okay.
No.
Wait for it. What if I cut it right down the middle right here? Okay. You can cut it even right here. Okay, so if you cut this in half, they would both look the same. Oh, this is, they really would. Yeah. I know it's kind of hard to tell because it's like at weird angles, but if I do this, it would be symmetrical.
Okay.
Okay? It would be different if it was like, if there was like a whole other amount, you know, like, but all of those are islands. It's like this side, this hydrogen's in there.
But if you separate like another amount, it wouldn't be the same because it's cut in half and they each have one part of the
Wait, so
same.
what's the point of this?
Yes. But then it depends what's connected to that molecule. Okay? So you'll see some other ones where they're not. Good question. Questions? Anyone need help?